I apologize if you're just turning on this video. I forgot to hit record. I don't know what our quiz is. Don't ask me for a second. Okay, so we were just working through example 1. I've already done some warm-ups. Yeah, sorry about that. So anyway, we're testing a point. We're testing 0, 0 to see if 0, 0 is in the shaded portion or not. We plug it in, we get 0 is less than negative 1. Tell me, is 0 less than negative 1?
Yes. No.
False. So does 0, 0 get shaded? So the parabola itself is like a border between the shading and not shading. So 0, 0 is kind of on the outside of the parabola. It's not going to get shaded. The inside will get shaded. Can you tell from back there that my graph is dashed?
I can, but it's a little hard.
Okay, so I'll make it more obvious then, because it sometimes gets hard to tell when you start shading if it's dashed or not. Then keep in mind, I have to grade your papers when you're doing a quiz or test, so make it obvious.
I was writing a note that says dashed. In case.
You can do both. Yeah. About what?
So when you tested it, so 0 is not less than negative 1. So why is it? Oh,
This is a false
negative 1.
statement.
Okay.
This is a false statement, and 0, 0 was here.
Okay.
So because it's false, 0, 0 is not a solution, so it cannot be in the shaded portion. Okay. All right, we're going to go to the next one, and I'm changing inequality number 2. So that's why I said don't work super far ahead. I'm changing inequality number 2. I'm going to change it to be x plus 3 and x minus 1, like in a different form. Still y is greater than or equal to, it's still that. And the reason why I did that is because, so we already did one that was in standard form. This next inequality number 1 is in vertex form, and inequality number 2 is now in intercept or in factored form. I just want to make sure we reviewed all the different forms so that when you have them in your assignment, you remember what to do. So this one's vertex form. And then this one is intercept form. Now we are graphing both of these on the same graph. So what I'm going to do first is I'm just going to graph equate inequality number 1. And I told you it's in vertex form. If it's in vertex form, you can use transformation. You might be able to look at this equation and use transformations without any work. Okay, it's okay. If that's the case, then your work on your assignment would be use transformation. However, some of us forget, and the table is really helpful, especially when we get to harder transformations. So I'm going to do this with a table just for review. So even if you know how to do it without the table, let's do it with the table in our notes, just to review, okay? So this is a quadratic. So I'm going to go use my quadratic parent function value. Do we remember, which by the way will be on our exam in December, the quadratic parent function value?
Negative 3, negative 2, negative 1, 0, 1, 2, 3.
So those are the x's, negative 3, 3, and then the y's, what do we do to get the
4,
y's?
1, 0, 1.
So what are you doing? You're squaring them, yes. 9, 4, 1, 0, 1, 4, 9. Perfect. So those are our squared, oh my, this quoted, exceeded. that is the squared value. I'm going to pause this real fast. Okay, so then we're going to think about transformations. What is that negative? What does that negative mean out front? Reflection in the x-axis. That means it's reflecting over the x-axis. That is what kind of reflection? Vertical or horizontal? Alright, heard both answers. Which way is it reflecting if it's in the x-axis? That's vertical, up and down. The x-axis is horizontal, but we're reflecting vertical. Because it's vertical, that's why we put it on the y side, we multiply by -1. Why would I be reviewing this if we've already covered it? Why, Danny? Why? Oh, I can see the future? Yeah. Totally! It's totally because I can see the future. Awesome, yeah. Okay, so here's the real answer besides I can see the future. That's totally the real answer. Because it'll be on your exam, and because we're going to do transformations in like every single chapter. So guess what we're doing in chapter 5? Guess what we'll do in chapter 6? Guess what we'll do in chapter 7? Transformation. So going over it is helpful. Yeah, it is. There's like a few main ideas. One is graphing, and so using transformations is really helpful. And then another main idea is solving graphs. So the factoring and the quadratic formula and the complete the square. Those are like two of the biggest things in algebra. Factoring is going to keep coming up over and over again as well. Okay. All right, so we're going to multiply all of our y's by -1. And then, after that, we have a +3. And remember, the +3 is not on the inside. It's on the outside of the square. On the outside of the square, meaning, is it vertical or horizontal?
Horizontal. +3.
That's if it's inside the box.
If it's inside the x, it's horizontal. It is up 3, which is vertical. So we're going to add 3 to the y side. And then when you graph it, you graph the x column with your outermost y column. And yeah, that may have taken a little bit longer because I made the table, but you might need a table when you have a stretch or a shrink. So I wanted to review the table. We did not have a stretch or a shrink, so you could have done this without the table. Reflection, up 3, easy. Well, that was my next question. Is it solid or dashed? It's dashed because it's not equal to. So I'm going to connect this with dash, and I'm going to make it look like a dash. What happens if you're using pen, and then you accidentally make it a solid, and you realize later it's dashed? I guess so.
Why not?
No. You like go over it, and you make it obviously, and then it's dashed. I'll do it.
White out.
Or white out, yeah. So now we're going to test a point. So what point can I test for this one? What would be a good point to test? 0. Sounds good to me. So 0 less than -0 squared plus 3, 0 less than 3. Is that true?
I don't think so. Yeah, yes.
So that 0, 0 gets graphed. By the way, can you tell how light I just graphed? See how light that is? Well, it's up here. I can see it better than you can. I just did it really, really, really light because that is not the final answer. I got 0, 0, and it worked. So 0, 0 has to be shaded. It's either inside of the parabola or it's outside the parabola because you want to see them. Okay, so now we're going to do number 2. Equation number 2 is y is going to equal to x plus 3 and then x minus 1. So that is in intercept form. So let's review. How do we graph when it's in intercept form? They're x-intercepts, but how do I find the x-intercept? We're going to set them equal to 0. So I have x plus 3 equals 0 and x minus 1 equals 0. So you're setting the factors equal to 0. X equals -3, x equals +1. These are x-intercepts. -3, 0, 1, 0. So now I'm using a different color so you can see more easily when I'm graphing right now. You can totally use your pencil still, it's fine. My penny reads it. If I make a mistake. Or you just take your chances. After we find the x-intercepts, what do we normally do to graph now? Because that's only 2 points. Axis of symmetry, how do we find it from the x-intercepts?
It's in the middle.
Right in the middle, the average, right in the middle, that is at x equals. What'd you say? You can do whatever you want. You're going to see when I'm done what the actual answer looks like. Okay? Alright, once I have the axis symmetry, now what can I find? Yes. It is the average of those two x-intercepts, so I can add up -3 plus 1 divided by 2, or I can look at the graph and say it's right in the middle. Okay, so now, vertex, by plugging in -1 to my x's, so we'll have -1 plus 3 and -1 minus 1. So 2 times -2 is -4. So my vertex is at -1, -4. I only have 3 points. How could I find 4 and 5? You could plug in a number. What would you plug in?
Oh, heck, you know, you just gotta know if you in. It is just 0 and -3. What are you talking about?
I don't know. What are you talking about?
What are you talking about?
What are you talking about?
Oh, wait, no, it's not so. You said we, yes, it is. What are you talking
Awesome.
about?
What are you talking about? Because I want you to explain.
Nah, that's cool. Don't even worry about it. Or tell him, I got an answer.
It's not always up 1 over 1, but
There's no stretch or
there's
strain.
no stretch or strain. So you could go out 1, up 1, out 2, up 4 if you wanted to. You could plug in a point to check, to find you plug in an x to find the y, or we didn't even find the y-intercept. So you can also find the y-intercept.
Is the answer where they overlap?
It is. So I'm going to find the y-intercept real fast. But you guys totally use that up 1, out 1, up 1 thing, because that's how I would totally do it if I was trying to do the least amount of work. Is this one solid or dashed?
Solid.
Solid. And then we need to test a point. What point could I test? Sounds good to me. I get that 0 is greater than or equal to -3. The question. You know the parent function is always like 1, 1, 2, 4, 3, 9. So this does not have a stretch on it. So instead of finding the y-intercept, some people are just like 1, 1, 2, 4, 3, 9. And when you graph it through your assignments, basically you can choose what you want to do. I'm just going through everything that you could do. Okay, so I tested that. Is this true or false? Is 0 greater than a negative number?
Yes.
True. So that means that 0, 0 does get shaded. That means I'm going to shade above or inside the parabola. But the answer itself is where the two overlap. So what I did was I made it really, 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 really light. Where the two overlap is the answer. So I'm going to make it obvious that this part is the solution. Okay, you see how I made that part obviously the solution. Now, when you look at this, how many numbers did I just shape?
Basically almost everything.
I would.
So there are, you guys are way more on top of their class.
Thanks. I'm a tall man.
Yeah, for real.
We're smarter.
In here, no, you're just you realize, or at least the people who are yelling out, realize that in there's all kinds of decimals in between just the numbers that are there. There's infinitely many numbers that I just shaded. So when I ask for the solution, you cannot write down an ordered pair where they cross, because all the ordered pairs that are shaded twice is where they cross. So you can't write down a solution, you just have to show it with the graph. These are the only way you can show it is the graph. The only way you can show your solution. Okay? Yeah.
How come when we were just doing it, we only did for points? Is that because it's like inequality?
I don't know what you're asking about. When we just did what?
Okay, the last one we're defining.
Oh, yeah, because those were equals.
Okay.
Right? And we just had to find where the two crossed, which you could find, like, in pre-calc. In pre-calc, they have to find the intersection points. You know, they have to find this point and that point. So you can find those, but the solution itself is all the shading part. Okay? When it's equal sign, you're just going to have where they cross. When it's less than or greater than, that's just the shading part. Okay? Now, there's example 4, which says student practice. I want you to try this. You should have some work here, even if the work is words saying, I use transformations. You should have some verification of how you got your graphs. I'm going to come around and check those, and after I check those, we're going to go to number 7 in the assignment that I passed out. And if I skipped you when I was passing assignments out, I'll get your copy. So I'm going to come around and check those, and then your assignment is that other packet that I handed out.